All right, in Chapter 5, we are going to get into the concept of elasticity. And elasticity is going to apply to a lot of the economic concepts we've already talked about, specifically within markets. So we're talking about elasticity of demand and elasticity of supply, and then also some of the shifters of demand and supply. So there's one of the shifters of demand is change in income and how that impacts our demand for normal goods, or our responsiveness, how responsive we are to an income change. And so we'll look at income elasticity. We'll look at cross-price elasticity of how the price change of one good, how responsive will the demand change be for its complement or for its substitute. So elasticity, by definition, is what we call responsiveness. Think about elasticity in the waistband of your sweatpants, right? It's elastic, it can bend, change, move, it responds to whatever force it's put on. In this case, we are going to look at how responsive, right? How responsive quantity demanded is going to be to a change in price. So we're going to start with price elasticity of demand. And we understand law of demand, or at least we should, that as prices increase, right, the quantity demanded moves in the other direction. Price goes up, quantity demanded goes down, law of demand. The question with elasticity then gets to be is, well, by how much? So as price increases, how responsive will quantity demanded be to that price change? So if you think about in terms of some unit of a good that costs $1, and if it moves in price from $1 to $1.10, it increases by 10 cents or 10%, what will be the percentage change in quantity demanded? We know that the quantity demanded is going to go down, but by what percent? If we see an increase in price by 10%, what will be the corresponding percentage change in quantity? Will it increase or decrease by 10%, by less than 10%, by more than 10%? So that is what we're getting into with this idea of elasticity. And there's some math involved. So we use what we call the midpoint formula. This means we're going to take the average price change and average quantity change. That way, the elasticity value is going to be the same no matter if we are increasing or decreasing either price or quantity. There are other ways to do it. There's taking it on the arc, but we're not going to worry about that. We're going to stay consistent using the midpoint formula, taking the average. That way we can calculate elasticity uniformly, whether we're going from $1 to $1.10 or from $1.10 down to $1. Depending on which direction you're going, you're going to see a different percentage change because obviously your numbers are a little bit larger at $1.10. So this is the formula that we're going to use. So this is ED, stands for elasticity of demand. A triangle, for math people, we know that means change. So we're going to take the change in the quantity divided by quantity 1 plus quantity 2. So here's the average part. So we add our two quantities together, what our original quantity was, what our new quantity is, and we divide that by 2. That's the average. So that's our percentage change, the average percentage change in quantity. And we're going to divide that by the percentage change, the change in price. Okay, the change in price divided by price 1 and price 2. Those up, and then divide it by 2 to get the average. So essentially we're getting the percentage change in quantity divided by the percentage change in price. That is going to allow us to it's going to come up with a value, and that value is going to be important for us to determine, okay, is the demand, price elasticity of demand, is it what we call elastic, inelastic, or unit elastic? And we'll get into those values here a little bit. So price elasticity of demand, ED. Okay, we know the law of demand is price and quantity are demanded are inversely related, and because they are inversely related, it's a negative relationship. So when we're talking about the price elasticity of demand, our value will always be negative, always. Because of that, and because some economist somewhere got sick of dealing with negative numbers, we always take the absolute value of price elasticity, so that way we always make it positive. So when you do this, and we'll work through one here shortly, you're always going to get a negative value, but we take the absolute value to make it positive, because reason why we just, I guess, don't like to deal with negatives all the time. So that's how that will work here. So here's our example. We're talking about demand for tacos, and here's our demand curve. We understand how these work. So here's our price. We're going from $1.10 down to 90 cents. So we're seeing a price decrease. Okay, a price decrease. Law of demand says as prices fall, quantity demanded is going to go up. So we're going to go from 95 to 105. Okay, so price of tacos drops from $1.10 to 90 cents. The quantity demanded increases from 95,000 to 105,000. We'll just say 95 and 105 to simplify our values here a little bit. So when we're looking at this, okay, we start with quantity, okay, and we are going from 95 up to 105. That is our, there we go, that is our quantity change, okay, and our price. We're going from $1.10 down to 90 cents, so that change, right, you see that is a negative 20. Quantity, okay, change is a positive 10. So if we go back to our formula quickly, okay, here's our formula. Write that down here. We got change in quantity divided by change in price divided by the average, price 1 plus price 2 divided by 2. I'm going to show you what I did here. There, all right. My face out of the way. All right, so here's our formula. Change in quantity divided by quantity 1 plus quantity 2 divided by 2. That gives us the average. Again, this is the midpoint formula. And we're going to divide that by the change in price. Quantity always goes on top, right? Divided by the change in price. And we got price 1 plus price 2 divided by 2 to get the average. So let's map through this one here quickly. So our change in quantity, we said was 10. So we start here with 10. And I'm just filling this out here. So we've got quantity 1, which was 95, plus quantity 2, which was 105. Divide that by 2. I'm going to go step by step. You'll be able to whip this out in your head here in no time. Okay, so we got divided by the change in price. We said it was negative 20 cents. We've decreased in price 20 cents. And we're going to take price 1, which was 1.10, plus 90 cents. Divide that by 2. So I've taken these values and plugged them into our math formula here. And this is going to give us our elasticity of demand value. So let's go a little bit further here. We know 95 plus 105 is 200. We divide that by 2. That gives us 100. So our next step looks like 10 divided by 100 divided by, now we got $1.10 plus 90 cents. That gives us $2 divided by 2 gives us $1. Okay. So here's our next step. If we take 10 divided by 100, that's going to give us 0.1, right? 0.1. We're going to divide that by negative 20 cents, or negative 0.2 divided by 1 is going to give us negative 0.2. Anything divided by 1 will give us the same. Okay. So now we take our 0.1 divided by a negative 0.2. And, sorry, there we go. And if you take negative 1 divided by negative 0.2, that's going to give you negative 0.5. Remember, we take the absolute value of this. So our elasticity of demand for this is equal to 0.5. Okay? So what does that value mean? What does 0.5 mean? And why is that important? Well, if we do this in terms of, okay, percentages, okay, that's 50%. We should understand that, I hope. But let's go back here for a second. If the percentage change in quantity and is greater than the percentage change in price. Okay, so if we have a elasticity value, elasticity of demand value between 0 and 1, which we do, right? It's 0.5. We are going to say that that demand is inelastic. It's relatively not very responsive. So what that means is a change in price has a relatively little effect, lesser effect on the quantity demanded. So if you go back to our original math here, you look, okay, our percentage change or average percentage change here, come down here, this is our change in quantity. 0.1, it's 10, and we have here, it's 20%. So our average change in price is 20%. That means going from $1.10 down to 90 cents is a 20% change in price. Well, this 20% decrease in price led to only a 10% decrease in quantity demanded. That means it takes a larger increase or decrease in price, one way or the other, to have that amount change in the quantity demanded. So in this case, 0.5, right? If we see, we can allow this value, we're only going to see half or 50% of the change, which means if we see a 20% change in price, we're only going to see a half of that change in the quantity demanded. So 20% change in price leads to a 10% change in the quantity demanded, regardless of which direction we're going. And another way that you can kind of then take that and find that out, what if I wanted to do a 40% change in price? Okay, if I wanted to know, I wanted to decrease my prices by 40%, what impact would that have on my sales? Well, okay, I can just take whatever my quantity is. Okay, if I want to do 40%, multiply that by 0.5, I know that's going to be 20. So a 40% decrease in my price is going to lead to only a 20% increase in my sales. That's how we use that in a business model. Okay? If this value, okay, is greater than 1, so if we were to calculate, and we'll do another one here in another video shortly, but if our elasticity of demand is greater than 1, like 1.5, that means a change in price has a relatively larger effect on the quantity demand, and we call that elastic demand. Okay, so a 10% increase in price is going to lead to a greater than 10% decrease in quantity demanded. That's what we call elastic demand. That means a relatively smaller change in price leads to a relatively larger change in the quantity demanded. All right. I'm going to cut this video off here now. I'll work through a few other samples to help you with that, but hopefully that helps give you some idea and makes a little sense.